This video going over the classwork from 222 on adding integers and rational numbers. It says today you'll continue to explore how to combine integers, positive and negative whole numbers, and zero, and rational numbers, fractions and decimals, lengths in multiple ways to find a new length. You'll also continue to learn how different combinations can be written with numerical expressions, such as 3 plus 3 plus negative 2 plus 11. So this is a continuation of what you did with Cecil. So 3 plus 3, remember guys, 3 plus 3 is 6, plus negative 2 plus 11. This would be 4 plus 11 is going to equal 15. So the first part of this, it said, find the length of the tightrope if each expression for rope's lengths begin below starts Cecil at point A and it has an end at point B. Assume the numbers represent lengths in feet. So when we add a negative number, it's kind of like we're subtracting. So I actually always add the positive numbers together first. So I would do 8 plus 2 is 10, plus negative 3. 10 minus 3 is going to be positive 7. So for B, I would add 7 plus 2 plus 5. 7 plus 2 is 9, plus 5 is going to be 14, and 14 plus negative 9 is going to be 5. I could have also seen that once I got 9, a negative 9 would have made it 0. 5 plus 3 is going to give me 8, plus a negative 5 is going to give me 3. Okay. The next set of problems says, for Cecil's new act, his tightrope is 5 feet. Part A says, if he begins at point A, write 2 expressions that will make him end at point B. What do these expressions have in common? So I can write an expression. The easiest one might be to write just 3 plus 2. I can also do something like 8 plus 2 plus negative 5 would work too. There's several different ways to do it. And what all the expressions have in common is they all equal 5. Okay. So part B says, explain why 5 plus 2 plus negative 2 is equivalent to the same as telling Cecil to move 5 feet to the right. So 5 plus 2 plus negative 2, 2 plus negative 2 equals 0. So then 5 plus 0 will equal 5. So adding opposites will always get us to 0. So Cecil will move to the 5 to the right. Okay. Will 5 plus 2 plus negative 2 plus 2 plus negative 2 get Cecil to point B? Will 5 plus 2 plus negative 2 plus 3 plus negative 3? How would you describe his movement in this case? The answer is yes, because we are adding opposites. And he is going back and forth. Okay. Oops, one slide too far. It says, what if Cecil's tightrope was a number line, like the one shown below? How can you represent negative 2 plus 3 using a number line? So if I drew a number line similar to the one that I have up there, I would start at negative 2, and I would jump forward 1, 2, 3. So I'd get positive 1. So negative 2 plus 3 equals positive 1. The next question asks us, it says on the same number line, start at 3 and represent 3 plus 2 and 3 plus negative 2. If we had done this in class, you would have inserted a picture on your number line. How are these two computations similar and how are they different? Here's 3. So 3 plus 2, I would start at 3 and go forward 1, 2, and end up at positive 5. So this is 3 plus 2. 3 plus negative 2, I would go backwards and end up at positive 1. So how are they the same and how are they different? So they're moving the same amount. But in different directions. Okay, part C says, describe how two computations, 8 plus negative 5 and 8 plus 5, would be related if you represented them on a number line. So how would they be related? So they would both move 5 spaces. Would move 5 spaces, but in opposite directions. And they both start at 8. So absolute value is the distance from 0. The absolute value, just like distance, is always positive. So you guys will notice that negative 2, the absolute value of negative 2 equals 2. The absolute value of 3 equals 3. They also work as a grouping symbol. So like if I put 2 plus 8 plus negative 11 inside absolute value symbols, 2 plus 8 is 10, plus negative 11 would be negative 1. But since they're in absolute value symbols, the answer is actually positive 1. Okay, so let's try a couple of these. So it says, in previous course, you may have learned that absolute value is the value of a number without regard to its sign, or the distance a number is from 0 on a number line in either direction. And that symbol, the absolute value of x, is used to indicate the absolute value of any number x. Evaluate each expression value below. Absolute values work like a grouping symbol. You do not do what's inside the lines first and then find the absolute value. So A, negative 20 plus negative 5 is negative 25. But then I have to take the absolute value, so I get positive 25. B, 45 plus 7 is 52. Since it's already positive, the answer would be positive 52. 8 plus 81 is 89. The opposite of the absolute value, though, is negative 89. So that's the only time absolute value can become negative if there's a negative sign outside. D, 0 plus negative 3 is negative 3. But the opposite of the absolute value of negative 3 is still going to make it negative 3. For Cecil's newest act, he starts at point A on the left end of his tightrope, walks on the tightrope, turns around, sometimes many times, and then ends up back at point A on the left end of his tightrope. Work with your team to write at least 3 expressions that show how Cecil could move and still start and end at the same point. So, for example, I could write negative 3 plus 3. I could write negative 10 plus 10. 8 plus negative 8, as long as he goes backwards or forwards, and backwards or forwards the same amount. So then it says build 3 more expressions similar to the expressions you wrote in part A. For your 3 expressions, do 1 with 2 numbers, 1 with 3 numbers, and 1 with 8 numbers. So 1 with 2 numbers would be similar to what I did here, negative 4 plus 4. 3 numbers, I could do 2 plus 3 plus negative 5, as long as my answer equals 0. And with 8 numbers, I'm just going to do 2 plus negative 2, plus 2 plus negative 2, plus 2 plus negative 2, plus 2 plus negative 2.